Hello and welcome to this video. In this video, we are going to solve Cambridge International AS and A level paper 1, Pure Mathematics 1, 9709/12, February-March 2024. Find the exact value. Let's rewrite this function as integral 3 to infinity 2 times x power minus 2 dx. Let's integrate this one. 2 times x power, increase the power of x by 1, so negative 1 divided by the new power, which is negative 1, and this is equal to negative 2 times x power minus 1, or we can write this as minus 2 divided by x. Now let's apply the limits. The upper limit is infinity. Minus 2 divided by infinity is nothing but 0, plus 2 divided by 3, which is nothing but 2 over 3. The next question, the curve shown here is y is equal to k sine 1 over 2x. So when does sine reach a minimum? For the sine function sine theta, the first minimum occurs when theta is 3 pi over 2. In this curve equation, theta is 1 over 2x. So 1 over 2x is equal to 3 pi over 2. Multiply both the side by 2. We get x is equal to 3 pi. At a minimum, sine theta is negative 1. That is, sine 1 over 2x is negative 1. Substituting this in the curve equation, we get y is equal to k times negative 1, which is equal to negative k. So the coordinates of point A is 3 pi comma negative k. The next part of the question. Here, a sequence of transformation is applied to the curve y is equal to k sine 1 over 2x. The first transformation applied is translation of 2 units in the negative y direction. So the given curve y is equal to k sine 1 over 2x transformed into y is equal to k sine 1 over 2x minus 2. The next transformation is reflection in the x-axis. Reflection in the x-axis means f of x will become minus f of x. So y is equal to minus of k sine 1 over 2x minus 2, which is equal to 2 minus k sine 1 over 2x. This is the equation of the new curve after applying the transformations. Next, let's find the coordinates of point A in the new curve. The initial value of A in the original curve is 3 pi comma negative k. After applying the first transformation, that is translation of 2 units in the negative y direction, here only the y value changes. So 3 pi comma minus k will become 3 pi comma minus k minus 2. Next, apply the second transformation, which is reflection in the x-axis. So here f of x becomes minus f of x, that is only the y value changes. So 3 pi comma minus of minus k minus 2. So this will become 3 pi comma k plus 2 is the coordinate of the point on the new curve corresponding to A. We are given dy by dx equal to 3 times 4x plus 5 the whole power 1 over 2. Integrate to find y. Y is equal to integral 3 times 4x plus 5 the whole power 1 over 2 multiplied by dx. 3 times the base 4x plus 5. Increase the power of the base by 1. So the power will be 3 over 2. The whole thing divided by the power 3 over 2 times 1 over the coefficient of x inside the bracket, which is 4, plus c. So the equation of the curve is y is equal to of times 4x plus 5 the whole power 3 over 2 plus c. Use the point 1, 9 to find c. 9 is equal to 1 over 2 times 4 times 1 plus 5 the whole power 3 over 2 plus c. So 9 is equal to 1 over 2 times 4 plus 5 is 9, 9 power 3 over 2 plus c. 1 over 2 times 27 plus c, which is nothing but 9 is equal to 13.5 plus c. So c value is 9 minus 13.5, which is negative 4.5. Now find a using the point 5, a. Substitute 5, a in the equation of the curve. So a is equal to half times 4 times 5 plus 5 the whole power 3 over 2 minus 4.5. A is equal to half times 25 power 3 over 2 minus 4.5, which is equal to half times 125 minus 4.5. Half times 125 is 62.5 minus 4.5, which gives 58. So the value of A is 58. Next, we prove the identity step by step. First, expand the square. Sin theta plus cos theta, the whole square is sin square theta plus cos square theta plus 2 sin theta cos theta minus 1, then the whole thing divided by cos square theta. Now use the identity sin square theta plus cos square theta is equal to 1. So the numerator becomes 1 plus 2 sin theta cos theta minus 1. The 1 and negative 1 gets cancelled. So we get 2 sin theta cos theta, the whole thing divided by cos square theta. Now simplify this cos theta, we get 2 sin theta divided by cos theta. Sin theta divided by cos theta is nothing but tan theta. So we get 2 tan theta. So hence we proved the identity. Next, the left hand side expression is nothing but 2 tan theta. So we get 2 tan theta is equal to 5 tan cube theta. Now bring all the term to one side. So we get 5 tan cube theta minus 2 tan theta equal to 0. Now let's factorize this one by taking tan theta commonly. So tan theta times 5 tan square theta minus 2 is equal to 0. Now solve each factor. Tan theta is equal to 0, which gives theta as 0. The next factor is 5 tan square theta minus 2 is 0. So add 2 on both the sides. So we get 5 tan square theta is equal to 2. Now divide both the side by 5. We get tan square theta is equal to 2 over 5. So tan theta is plus or minus square root of 2 over 5. So theta is nothing but tan inverse of plus or minus square root of 2 over 5. So we get two values here. Theta is equal to tan inverse of positive square root of 2 over 5 and theta is equal to tan inverse of negative square root of 2 over 5. For theta is equal to tan inverse of square root of 2 over 5, we get the value 32.3 degree. And for theta is equal to tan inverse of minus square root of 2 over 5, we get the value minus 32.3 degrees. So theta takes the value 0 and plus or minus 32.3 degrees. Next, here a curve equation is given. Y is equal to 3 divided by 2x square minus 5. Let's rewrite this as y is equal to 3 times 2x square minus 5 the whole power negative 1. Now differentiate this to find the gradient of the tangent. Dy by dx equal to 3 times the power, which is negative 1, times the base 2x square minus 5 the whole power. Decrease the power by 1, so we get the new power as negative 2 times. Now differentiate the x term inside the bracket, so we get 4x. This is equal to minus 12x whole thing divided by 2x square minus 5 the whole square. The gradient of the tangent at 2, 1, that is when x is equal to 2, is minus 12 times 2 divided by 2 times 2 square, which is 8. 8 minus 5 the whole square equal to minus 24 divided by 9. Divide the numerator and denominator by 3. So we get minus 8 over 3. This is the gradient of the tangent. Now, gradient of the normal is nothing but the negative reciprocal of the gradient of the tangent. So, gradient of the normal is 3 over 8. Now, the equation of the normal through the point 2, 1 is y minus 1 is equal to 3 over 8 times x minus 2. Now, multiply by 8, we get 8y minus 8 is equal to, expand the bracket, so 3x minus 6. Now bring all the terms into one side, so we get 3x minus 8y plus 2 is equal to 0. Next is a binomial question. We are given that the coefficient of x cube in 2 plus ax the whole power 4 times 5 minus ax is 432. The first step is expand 2 plus ax the whole power 4 up to x cube terms. 2 plus ax the whole power 4 is equal to, using the binomial theorem, this is equal to 2 power 4 plus 4 times 2 cube times ax plus 6 2 power 2 times ax the whole square plus 4 times 2 times ax the whole cube plus ax the whole power 4. Let's simplify this. This is equal to 16 plus 32ax plus 24a square x square plus 8a cube x cube plus a power 4 x power 4. Now multiply this by 5 minus ax and collect the x cube terms. To get an x cube terms in the product, we have to multiply 5 by 8a cube times x cube, so which gives the x cube term, and minus ax should be multiplied by 24a square x square, which gives minus 24a cube x cube. So the coefficient of x cube is 40a cube minus 24a cube, which is equal to 16a cube. So it's given this is equal to 432. So 16a cube is 432. So a cube is 432 divided by 16, which is 27. And a is nothing but 3. Next, it's given the line meets the curve at a single point. So the line is a tangent to the curve. Substitute y is equal to x plus 5 into the curve equation. So we get 2x square plus 3 times x plus 5 the whole square equal to k. Now expand this, we get 2x square plus 3 times x square plus 10x plus 25, which is equal to k. Now expand the bracket, so we get 2x square plus 3x square plus 30x plus 75 is equal to k. Bring all the term into one side, so we get, and let's simplify this. So 5x square plus 30x plus 75 minus k is equal to 0. Let's use the condition for a single point. For a quadratic to have one solution, its discriminant must be 0. That is b square minus 4ac is equal to 0. Here b square is 30 square minus 4 times a is 5 and c is 75 minus k, which is equal to 0. Let's solve this equation for finding the value of k. 900 minus 20 times 75 minus k is equal to 0. 900 minus 1500 plus 20k is equal to 0. 900 minus 1500 is negative 600. Now add 600 on both the sides, so we get 20k is equal to 600. Now divide both the side by 20, so we get k is equal to 30. So the value of k is 30. Next part of the question, find the coordinates of P. So let's use the part A answer, which is k is equal to 30. Let's substitute this in the equation where the curve and the line intersects. So 5x square plus 30x plus 75 minus k is equal to 0. In that, let's substitute k as 30. So we get 5x square plus 30x plus 75 minus 30 is equal to 0. On simplifying this, we get 5x square plus 30x plus 45 is equal to 0. Divide all the term by 5. We get x square plus 6x plus 9 is equal to 0. This is nothing but x plus 3 the whole square. So x plus 3 the whole square equal to 0. So x plus 3 is equal to 0. Subtract 3 on both the sides. So we get x equal to negative 3. To find the value of y, substitute x equal to negative 3 in the equation y is equal to x plus 5. So y is equal to negative 3 plus 5 is equal to 2. So the coordinate of P is negative 3, 2. Next, this is an arithmetic progression question. It is given the first term is 6, that is A is 6, and the 10th term is 19.5, that is A plus 10 minus 1 times D is 19.5. Substitute the value of A as 6 here, so we get 6 plus 90 is equal to 19.5. 90 is equal to 19.5 minus 6, which is 13.5. Now divide both the side by 9. We get D is equal to 13.5 divided by 9, which is equal to 1.5. Now we know the value of A and D. To find the sum of the first 100 terms of this arithmetic progression, let's use the formula Sn is equal to n divided by 2 times 2a plus n minus 1 time d. Here a is given as 6 and d is 1.5 and n is given as 100. Substitute all the values here. So we get 100 divided by 2 times 2 times 6 plus 100 minus 1 times 1.5, which is nothing but 50 times 12 plus 99 times 1.5. Solving this, we get 50 times 160.5, which is 8025. The next part of the question, the geometric progression A1, A2, A3 is such that A1 is 24 and common ratio R is 1 over 2. Okay. The sum to infinity of this geometric progression is denoted by S. Let's calculate S. S is equal to 24 divided by 1 minus 1 over 2, which is equal to 48. Next, the sum to infinity of the even numbered terms, that is A2, A4, A6 is denoted by SE. What is A2 value? A2 value is A1 times the common ratio, which is 1 over 2. So 24 times 1 over 2 is 12. So A2 is 12. What is A4? A4 is 24 times 1 over 2 the whole power 3, which is 3. So the common ratio between these even terms is 3 divided by 12, which is 1 over 4. So in this case, the sum to infinity SE is 12 divided by 1 minus 1 over 4, which is 16. So S is 48 and SE is 16. Next, this is a function question. F of x and g of x are given. The first part of the question is given the the range of the function gf is gf greater than or equal to 39, find the value of k. So first let's calculate gf, that is substitute the value of f of x in g of x. So 5 times 3x minus 2 the whole square plus k minus 1, which is equal to 5 times 3x minus 2 the whole square plus 5k minus 1, and this is g f of x. Here the coefficient of 3x minus 2 the whole square is 5, which is a positive number. So you will get a curve like this, and this will be the minimum point of the curve. From this equation, which is in completing the square format, 5k minus 1 is the y coordinate of this minimum point, and it's given the range of the curve is greater than or equal to 39. We know from this to above is the range. Okay, so the minimum point here for the y coordinate will be 39. So 5k minus 1 is actually equal to 39. Let's solve this. 5k is equal to 40. Divide both the side by 5. We get k as 8. Next part of the question. For this value of k, determine the range of the function fg. So let's first calculate the composite function fg. So substitute the value of g in f. F g of x equal to 3 times 5x minus 1 minus 2 the whole square plus 8. Expand the bracket. 15x minus 3 minus 2 the whole square equal to 15x minus 5 the whole square plus 8. Here the coefficient of 15x minus 5 the whole square term is 1. That is positive 1. And this is in a completing the square format. Okay, so we'll get a curve like this. And this will be the minimum point. So this will be the range. So the range here, the y coordinate is 8. So the range will be f g of x greater than or equal to 8. Next part of the question, here g h of x is given. Find an expression for g inverse of x. Okay, we know g of x is 5x minus 1. Let's take this as y. Y is equal to 5x minus 1. Now interchange x and y, so we get x equal to 5y minus 1. Now rewrite this to make y as the subject. So x plus 1 is equal to 5y. Y is equal to 1 over 5 times x plus 1. So J inverse of x is 1 over 5 times x plus 1. So now we need to find the expression for h of x. It's given g h of x is 35x plus 19. Now multiply both the side by g inverse. So g inverse and g gets cancelled. So h of x equal to g inverse of 35x plus 19. Now in g inverse of x, for x substitute 35x plus 19. So we get 1 over 5 times 35x plus 19 plus 1, which is 1 over 5 times 35x plus 20, which is equal to 7x plus 4. So h of x is 7x plus 4. Next, we are asked to find the equation of the tangent at the point minus 6, 9. We know a tangent to a circle is always perpendicular to the radius drawn to the point of contact. So first let's find the gradient of the radius CP. Gradient of CP is 9 minus 5 divided by minus 6 minus of minus 4, which is equal to 4 divided by negative 2, which is negative 2. Next, the gradient of the tangent is perpendicular to the radius, so the gradient is the negative reciprocal. Gradient of the tangent is 1 over 2. So the equation of the tangent at the point minus 6, 9 is y minus 9 is equal to 1 over 2 times x plus 6. So y is equal to 1 over 2x plus 3 plus 9, which is 12. Next part of the question is find the equation of the circle in the form x square plus y square plus ax plus by plus c is equal to 0. Here we know the center of the circle and the radius also. So the equation of the circle is x plus 4 the whole square plus y minus 5 the whole square equal to square root of 20 the whole square. Now expand, we get x square plus 8x plus 16 plus y square minus 10y plus 25 minus 20 is equal to 0. So x square plus y square plus 8x minus 10y plus 21 is equal to 0 is the equation of the circle. Next part of the question is find the value of theta correct to 4 significant figure. It's given the circle intersects y-axis. So x is 0. Substitute x equal to 0 in the circle equation. So we get 4 square plus y minus 5 the whole square equal to 20. Y minus 5 the whole square equal to 20 minus 16, which is 2 square. So y minus 5 is equal to plus or minus 2. So y is equal to 5 plus or minus 2, which is 3, 7. So coordinate of A is 0, 7 and coordinate of B is 0, 3. AB is equal to square root of 7 minus 3 the whole square, which is square root of 16. Now we know the three sides of a triangle. So let's use cosine formula to calculate the angle. Cos theta is equal to square root of 20 the whole square plus square root of 20 the whole square minus square root of 16 the whole square divided by 2 times square root of 20 times square root of 20. Simplifying this gives 3 over 5. So theta is equal to cos inverse of 3 over 5. So theta is 0.9273 after correcting to 4 significant figures. Next part of the question is find the perimeter and the area of the segment shaded in the diagram. The perimeter of the shaded region is length of AB plus arc length AB. Length of AB is square root of 16 plus arc length is square root of 20 times 0.92729, which is 8.147. The area of the shaded region is nothing but area of the sector minus the area of the triangle, which is equal to 1 over 2 times square root of 20 the whole square times 0.92729 minus area of the triangle is of square root of 20 the whole square sine 0.92729. Simplifying this gives the area of the shaded segment as 1.27. Next, we are asked to find the exact coordinate of the minimum point M. To find minimum point, first find dy by dx. Here dy by dx equal to 2 times negative 2 over 3 times x power minus 5 over 3 minus 3 times negative 1 over 3 times x raised to the power negative 4 over 3, which is equal to negative 4 over 3 times x raised to the power minus 5 over 3 plus x raised to the power minus 4 over 3. Minimum point occurs when the curve turns, that is dy by dx equal to 0. So equate this dy by dx to 0. Now simplifying this, we get 4 over 3 is equal to x raised to the power minus 4 over 3 whole thing divided by x raised to the power minus 5 over 3. Simplifying this, we get x raised to the power 1 over 3 is equal to 4 over 3. Now take cube on both the sides. So we get x equal to 4 over 3 the whole power 3, which is nothing but 64 divided by 27. This is the value of x. To find the corresponding y value, substitute the x value in the equation of the curve. Y is equal to 2 times 64 divided by 27 raised to the power minus 2 over 3 minus 3 times 64 divided by 27 raised to the power negative 1 over 3 plus 1. Simplifying this, we get 2 times 9 over 16 minus 3 times 3 over 4 plus 1, which is equal to 9 over 8 minus 9 over 4 plus 1, which is equal to 1 over 8. So the coordinate of M is 64 over 27, comma, negative 1 over 8. Next part of the question is, here the curve and the x-axis intersects, that is y is equal to 0. Substitute this in the curve equation. So we get 2 times x raised to the power minus 2 over 3 minus 3 times x raised to the power negative 1 over 3 plus 1 is equal to 0. To solve this, take u as x power 1 over 3. Substitute this, so we get 2u power negative 2, that is 2 divided by u square, minus 3 times u power negative 1, which is nothing but negative 3 over u, plus 1 is equal to 0. Multiply by u square, so we get 2 minus 3u plus u square equal to 0. Factorizing this gives u minus 1 times u minus 2 is equal to 0. So the value of u is 1 and 2. When u is 1, x is also 1. When u is 2, 2 is raised to the power 3, which is 8. So x is 8. So the coordinates of A and B are 1, 0 and 8, 0. Next, to find the area, here the curve lies below the x-axis. So the area is negative integral and the limit is 1 to 8 y dx. For y, we have to substitute the curve equation, which is 2x power negative 2 over 3 minus 3 times x power negative 1 over 3 plus 1 dx. Integrating this, we get 2 times x raised to the power 1 over 3 whole thing divided by 1 over 3 minus 3 times x raised to the power 2 over 3 divided by 2 over 3 plus x. Simplify this, we get 6 times x power 1 over 3 minus 9 over 2 x raised to the power 2 over 3 plus x. Now substitute the limits. First substitute the upper limit, minus of 6 times 8 raised to the power 1 over 3, which is nothing but 2, minus 9 over 2 times 8 raised to the power 2 over 3, which is 4, plus 8, minus of, now substitute the lower limit, 6 times 1 minus 9 over 2 times 1 plus 1. Now simplify this, we get minus of 2 minus, this is 6 minus 9 over 2 plus 1 is 5 over 2. So minus of 2 minus 5 over 2 is 1 over 2. So the area is 1 over 2.